2429. All right. So here we have a downward electric field. Let me draw that first with a bunch of vectors. And it has a value. The electric field is downward and it has an intensity of 500. Oh, sorry, better read the right question. 300 newtons per Coulomb. So that means for every Coulomb of charge that you drop in this field, there will be 300 newtons of force acting on it. Right? It's a lot of force. But remember, Coulombs are very large units. So we're going to put a charge in the field, and it's going to be on a string. So let me just draw in there a string and a charged object. Now this charged object has some properties. It has a charge of 8 microcoulombs. I'm going to write it over here because I can't squeeze it in there. That's the charge on that object. And it also has a mass, which is given as 0.6 grams. Be careful. That means 0.1236 grams. Kilograms. Divide by 1,000. Got to put your masses in standard units. A lot of books and exercises make you do that extra step. So don't forget. Okay? Don't forget standard units. And the question then says, what is the tension in the thread? If A, we have a positive field, if the charge is positive, okay? So the first case is going to be plus 8 microcoulombs, and the other case is going to be minus 8 microcoulombs. Well, let's see what that does, right? Let's just look at our picture. A plus 8 microcoulomb charge, well, we can put our force of gravity, which won't change. So there's a force of gravity pulling on this object, okay? Now, if you have a plus 8 charge, let me just go in blue here with plus 8, then what will happen is that plus 8 will feel a force in line with the field. The field is always drawn in the direction that positive charge would sort of be forced. So that means that the electric force for the plus 8 is a downward force following the field. But if you change it to a negative force, I'll just put this one in yellow, then a negative force would be opposite and the electric force would go up. So the only real change is that in one case the electric force is down and in the other case the electric force is up. So now all you have to do is draw the net force in the blue case, which will be the electric force plus the gravity force plus the tension, right, in the rope. And if this is 0 because it's suspended, not moving, then what we can see here is if we I'm just going to look at some quick, the electric force is up, so there's a positive electric force, right? Oh, my mistake. This is the positive one, so the electric force is down. I should have looked at the picture first, right? So this is the blue condition here. We're talking about the blue one. So this is a negative downward electric force right here, right there. And gravity is a downward negative force. So we can put our mg in there. In fact, what I should do is change the Fe to its equivalent, which is QE, right? And then, of course, the tension is an upward force. So you get directions. So now all you have to do is figure out these things and put the proper directions in. Then what you're going to find is that QE will move to the other side. You'll add it to the gravity, and those will tell you how much the tension is. Now, in the other case, the only difference is you have 0 equals. And because we're now talking about the minus 8, we have the yellow electric force, which is up. And so all we do is change this to a positive QE for an upward force. We still have a downward gravity, and we still want to know what the upward tension would be. And in this case, you'll see what happens is you get mg minus QE is the tension. Because